Hi, everybody. A very good day for everyone. This is Bharat, Assistant Professor, Department of Electrical and Electronics Engineering, SNS College of Technology, Coimbatore. In a lecture series on the subject course, Industrial Machine Learning, we have been seeing various techniques under supervised, unsupervised, and reinforcement categories. Today, our topic is going to be about one of the algorithm, famous algorithm, that is K nearest neighbors algorithm. Come, let's get into the video to understand the concepts of K nearest neighbors. Simple analogy. We'll start the video with an analogy. Tell me about your friends, who your neighbors are, and I will tell you who you are. We have come across this famous quote. Okay, so with your knowing about your friend, we know to understand whom you are. So this process is involved in grouping, instance-based learning. So it's very similar to a desktop. All these things are desktops. What is KNN? Different names. K nearest neighbors, memory-based reasoning, example-based reasoning, instant-based learning, and lazy learning. What is KNN? A powerful classification algorithm used in pattern recognition. K nearest neighbor stores all available cases and classify new cases based on similarity measures. Example distance function. One of the top data mining algorithm used today. A non-parametric lazy learning algorithm, an instant-based learning method. KNN classification approach. An object, a new instant is classified by a majority votes for its neighbor classes. The object is assigned to the most common class amongst its k nearest neighbors, measured by a distance function. You can see a graph having a values of red, blue, and center point as a green. These are the various data. Distance measure. Compute the distance between the training records and the test records. Choose the k of the nearest records. Distance measure of continuous variables. Distance function. This could be divided into three categories. One is Euclidean, Manhattan, and Minkowski. Euclidean, square root of summation I is equal to 1 to k, x of I minus y of I 2. Manhattan, summation I is equal to 1 to k, x of I minus y of I, modulus of. Minkowski, summation I is equal to 1 to k, modulus of xi minus yi, the whole square, the whole power, 1 by 2, that is square root. Distance between the neighbors. Calculate the distance between new examples and all examples in the training set. Elucidate distance between two examples, x is equal to x1, x2 up to xn, y is equal to y1, y2 up to yn. The elucidate distance between x and y is defined as d of x comma y is equal to square root of I is equal to 1 to n, x of I minus y of I the whole square. K nearest neighbor algorithm, all the instances correspond to the points in a non-dimensional feature space. Each instance is replaced with a set of numerical attributes. Each of the training data consists of a set of vectors and a class label associated with each other. Classification is done by comparing the features vectors of different k nearest points. Select the k nearest example to E in the training set. Assign E to the most common class among the k nearest neighbors. So k nearest neighbor, we have taken a case as an example. Customer, age, income, no credit cards, and class. George, 35K, 3 class no. Rachel, 22K, 50K, yes. Steve, Tom, Annie, and John. So for all these cases, we see the distance from the John to this is. We are calculating the square root of the values for different k. How to choose k? If k is too small, it is sensitive to noise points. K, if larger k works well, but too larger k may include majority points from other classes. Rule of thumb is k less than square root of n. N is number of examples. 1 nn, 3 nn. Difference is, here is a noisy sample, here it is a good output. Every example in the blue shaded area will be misclassified as the blue class. Every example in the blue shaded area will be classified correctly as the red class. 1 nearest neighbor, 2 nearest neighbor, or 3 nearest neighbor is shown in the figure. So minus and cross and plus, minus cross plus and plus. So from the cross, we have 3 nearest neighbor, 2 nearest neighbor, and 1 nearest neighbor. K nearest neighbor of record, X are data points that have the K small distance to K. KNN feature weighting, scale each feature by its importance for classification. D of A comma B is equal to square root of summation K WK AK minus BK the whole square. Can use our prior knowledge about which features are most important. Can learn the weights WK using cross validation to be covered later. Feature normalization can be used to distance between neighbors could be dominated by some attributes with relatively large number. Example is given. Important to normalize those functions, mapping values to number between 0 and 1. Okay, this is the process of KNN classification for the given example. KNN classification of distance classified the different into different data. So this is the standardization variable. So what are the strengths of KNN? Very simple, intuitive, can be applied for data, and good classification. Weakness takes more time. Choosing K may be tricky, need large number of samples for accuracy. Thank you. Let's meet in the next video.